Okay, this video is solving trig equations using identities. We're going to do 5 equations, including your number 23. I'm going to explain some of what the book is doing. So, the first one is this one here that we're going to do, and we're going to continue on with that. So we have 3 cosine of theta plus 3 equals 2 sine squared of theta. Now, in this case, we're not establishing identities. We're just going to use the identities we have. Since we already know how to factor, there's not much we can do with this side. But on this side, I could write this as 2 times 1 minus cosine squared of theta. Now, when I do that, I can make a quadratic equation like I did in the first video. So basically, I'm going to move this stuff over on this side. So let me go ahead and, now I'm going to move this over here. So this over here is, let me erase that, is 2 minus 2 cosine squared of theta equals 3 cosine theta plus 3. Now, I'm going to subtract, I'm going to set all this to 0, so I'm going to subtract 2 and add 2 cosine squared of theta to both sides. So I'm going to do that first. This will give me 2 cosine squared of theta. I have this piece, so I have plus 3 cosine of theta. So I took care of that, and I'm going to subtract 2 here, and I get plus 1. And all of this now, since I subtracted all that, that equals 0. Then all I'm going to do is factor, and it's going to be 2 cosine theta plus 1 times cosine theta plus 1 equals 0. I make 2 separate tables and set each of this piece to 0 and this piece to 0. So in this case, I'll have cosine of theta equals negative 1/2. In this case, I'll have cosine of theta equals negative 1. And my total solution sets, I'm just going to put them all together, for theta would equal, for this one I'll have, for negative 1, I have this theta equals, this is negative 1. Equals pi. For these two here, I have, for this one I have 2 solutions, which is 2 pi over 3 and 4 pi over 3. I'm going to go ahead and add this to my solution set in pi. So I have 3 solutions. So all I did was use identities to put it back in quadratic form so I could factor. Okay, the next one we have is, and this is where you're going to use your double angles. Remember, for my double angles, basically what we were doing is just plugging in and substituting. Well, now that we have to solve, and again we're solving all of these on the interval between 0 and 2 pi, I'm going to use my double angles. So, I kind of want to make this quadratic in form. There's not much I can do here, pretty simple. But this I can write as one of my 4 formulas. I could write as 2 cosine squared minus 1 plus 3. And I'm going to go ahead and subtract this while I'm at it. So that's minus 5 cosine of theta equals 0. I'm going to clean this up, and I get 2 cosine squared. I'm going to put it in quadratic form. Minus cosine theta plus 2 equals 0, because I added those 2. It's just like saying again, 2x squared minus 5x plus 2 equals 0. When you factor this, you're going to get 2 cosine of theta minus 1 times cosine theta minus 2. Now, in this case, we have on this one right here, we have cosine of theta equals 1/2. And in that case, our answer would be pi over 3 and 5 pi over 3. That's what theta is. On this one, however, let me split it up, we have cosine of theta equals 2. Well, there's no such thing here, so there's no solution, no real solution here. So my two solutions are pi over 3 and 5 pi over 3. My next one is going to be cosine squared of theta plus sine of theta equals 2. Again, I'm going to put this, make this quadratic in form. Since there's not much I can do with him, I'm going to write him as terms of sine, which is 1 minus sine squared plus sine squared, or sine, and I'm going to go ahead and subtract him from both sides. So that's minus 2 and set this to 0. Now, I'm trying to plug up my iPad because the cord came out. Alright, so now clean this up, and we get 1 minus sine squared theta plus sine minus 2 equals 0. So this could be negative sine squared of theta, there's theta there too, plus sine theta, and this would be minus 1 equals 0. Basically, I just combined those two. Alright? Now what I'm going to do here, because I don't like my lead term here, negative, I'm going to negate this whole thing. You don't have to, but it looks nicer. So when I negate everything, I make everything opposite signs. And then I'm just going to factor. This is just going to be sine minus 1 times sine minus 1 equals 0. Basically, let me try to factor this again. Can we factor this? Because if this, the way I did it before, that you'd have to have a 2 here. We can't factor this. Remember the discriminant, if you had x squared minus x plus 1, and my discriminant was b squared minus 4ac. If this is negative, then we have no real solutions. So we have 1 minus 4, 1 times 1. So this would be negative 3, which is less than 0. So I have no real solutions here. We have complex solutions. You know, we do have eyes going on in here, but they want real solutions. Okay, the next one is sine of theta times cosine of theta equals negative 1/2. Alright, and remember I told you you're going to use that sine of 2 theta a lot. That equals 2 sine of theta times cosine of theta. You will use this a lot in calculus. If I cross multiply here and multiply the 2 and put it up here, then basically I have 2 sine theta cosine theta equals negative 1. Now, what I'm going to do is write this as sine of 2 theta equals negative 1. And here we go back to this prior section, and we're going to first solve for sine of theta equals negative 1. and that is at 3 pi over 2. So we have that. But we're really looking for what? 2 theta. So we set 2 theta equals 3 pi over 2 plus 2k pi. Divide everything by 2, so theta equals 3 pi over 4 plus k times pi. I'm going to move it over here. Theta equals 3 pi over 4 plus k times pi. Now we know we're seeking solutions between 0 and 2 pi. So we know we already have one. When k is 0, we have 3 pi over 4. Alright, because that would zero this part out, this part here out. Let's let k equal 1. So we have 3 pi over 4 plus 4 pi over 4, because this equals 1 there, so that's going to give us 7 pi over 4. And let's try k equals 2. K equals 2, we have 3 pi over 4 plus 2 pi over 8 pi over 4. That equals 11 pi over 4. 11 pi over 4 is bigger than 2 pi, so we have to disregard it. Now if you check k equals -1, then you're going to get 3 pi over 4 minus 4 pi over 4, and that gives you a negative pi over 4, which is not in between. It doesn't belong, let me do it that way, does not belong between 0 and what? 2 pi. So we only had 2 solutions here, and there they are. Okay, and the last one we're going to do is your number 23. And what is 23? Let me go to 23. We have same kind of issue here. So let's go to this one. 23. We have cosine of 2 theta equals cosine of theta. Now, again, there's not much we can do with this, but we can rewrite this. So on 23, what I want to do is write this one in terms, this right here in terms of cosine, since we already have a cosine here. So I'm going to use my double angle identity and write this as 2 cosine squared minus 1 equals cosine of theta. Now it looks quadratic in form now, so I move it over and I have 2 cosine squared minus cosine of theta minus 1 equals 0. I factor this and I get 2 cosine theta plus 1 and cosine theta minus 1 equals 0. Break this up, set both pieces equal to 0. So we have 2 cosine of theta plus 1 equals 0, and cosine theta minus 1 equals 0. In this case here, we get cosine theta equals -1/2, and this one cosine theta equals 1. If you look on your unit circle chart, your solution set would be 0 for this one. And for this one right here, you get 2 pi over 3, and you get 4 pi over 3. Okay.